Been quite a long one, hasn't it? So let's get yourself a bit more comfortable on it. So we get into the last activity, activity 5. So this is, I'm going to read from the screen up here. The final task booklet entry must evaluate. So the evaluation is comparing your proposal to what the existing. Okay, that's the evaluation of that. There are four bullet points here. I think they might be similar on most of the exams anyway. Success and limitations of the complete solution, indirect benefits and opportunities, the constraints and opportunities for technology-led modifications. Now, we've got to be careful here that you answer this. You've got to be careful here that you answer how the examiner's requiring. So let's talk about the first bullet point, the successes of there. Well, how well did it go for you? Okay, do you reckon you got something pretty smart? Did you manage to complete the whole exam expectations? Okay, you know what the client asked for. Have you answered everything there? Here is where you get the chance to discuss what went well with your proposal. Okay, and were all client expectations met as well? Did you add anything extra to the design? Remember, you must refer to the client brief for these parts to cover this. Okay, now when you're looking at the limitations, you can go down 2 routes. One's a good one, one is not so good. That's the one that's going to lose your marks. Okay, now this has to be specific for your proposal. Maybe some elements could not be met due to one reason or another. Okay, so it might be a time constraint that you just run out of time to do that. That's what you would have liked to do. An example of this, the aluminium tubing for the safety rails was there to stop the operator or user falling off. Okay, now the limitations here is you couldn't have a low one. It had to be of a certain height. So it had to be a minimum of such and such. And even the mid-rail had to be a minimum of such and such. Okay, these were under the guidance of working platforms through the HSE. So if you have, hopefully you have got something from the HSC of relevant bits and bobs, you've got a winner there. Now, what you don't want to be doing is discussing, might not be able to do the isometric drawing because you lack the skills. Okay, material properties might have been unknown, or the process you did not know very well. Okay, here's another one. Maybe you had some information missing from your research notes, and also you couldn't remember the health and safety regulations as well. That's not product related. That's coming down to limitations of you. So don't do that. Now, do not fall in that trap where you're coming down that route. It has to be relevant for the product. Now, second bullet point, as I say, indirect benefits and opportunities. So indirect benefits, I think, just looking at my list here, what have I got here? Right, okay. So the platforms, the handrails on the platforms that I used, well, basically made it easier for the user to push it down the corridor. Okay, so if it was just a normal platform without the rails, you have to bend down to move it. So with these rails here, you grab hold of them and push the thing along. It's just, I made the rails to make it safer, and you can use the rails to push it along. That's an indirect benefit. If you're looking down at the design, they moaned about it being not stable. So, and also at the same time, they wanted to be able to make it easier to step onto the top step of the top of the platform. So by adding that step where I did at 200 mil high in between the side plates, yes, it made it easier for the user to get on top. But the indirect benefit there, it actually stiffened that side of the assembly up. So that's a decent thing. It stiffened that side of the assembly up. So that's an indirect one. Just remember, that type of discussion is good. And if you go down the route and mention the price, oh, if I made out of this material, it's cheaper. Come on, no. You know, come on, that's a cheap shot. I chose it for that. Now, if it was built to price, we'll be making out, you know, with 3D printing and all that business. Oh, it breaks, you just print another one off. Okay, we're not going to go down that route. It's a poor choice of direction to follow if you're going to go down there. Now, opportunities. in that same bullet point is making use of advanced manufacturing techniques to produce the parts to assemble. So this will involve, well, actually will not involve, what it do is it will make handling of the material less, because you'll use an automated process. So if you go for laser cut profiles, so instead of the operator cutting them with the old hand shears, they put it on there on a laser cutter, that cuts all the parts out. All they have to do is de-ship the parts from the cut plate. That's all they have to do there. If you cut by hand, it's now labour intensive. So the opportunity is there. Use those advanced manufacturing techniques to reduce time. Okay, the good thing about it is using laser cutters is providing consistent sized parts. Okay, none of this, oh, that's top limit, that's bottom limit. It'd be consistent sized parts. Quicker manufacturer too, so you're saving time there. Maybe using robots take the bulk of the welding away from the welder, so less exposure to the fumes. That's a nice one to do, which can be seen as a positive improvement on there if you get the opportunity. Now, robots are quite expensive, and programming like this is a bit tasty as well, as I say. Now, thinking about improving the safety factor as well. So the original platforms, I think, only had 70 to 90 kilos added on there. So obviously, if someone's over the weight of 90 kilos, is that they'd be over the safe working limit of the platform. So the design has to have a bigger safety factor. That practically had nothing. So if I made it to hold 150 to 170, 75 kilos, anybody up to there, plus the tools and that business, will never come anywhere near that, the limit of the safety thing. Also, my design had the tool tray at the top. So instead of the engineer going up with a tool belt, the tools are up there on the top. And also, when it's finished with it, put the tools in the storage bit underneath, job done. That's a keeper. The constraints come down to the size and shape of the top and side plates. You were asked not to change this, okay? We don't know the reason why, but we were asked not to change that. So that was a constraint made by the client, okay? If you had free artistic license, you could have produced something different. It could have been easier to design on a larger platform, okay? Using aluminium extruded parts to build the frame, and using checker plate for the top plate. Only problem was we did not know how much space that would be available for that platform to go in. It might be that size for a specific reason only due to that. Now, some control panels are have some switch gear, and some of that switch gear is very heavy. Okay, using the top rails to rest parts on, so that top rail they put parts on as they move into the control panel, may damage the rails. So we don't want to do that. So this requires your operator not to use them for that purpose. So, you know, your constraints there, don't rest anything on the top, stick all your tools on that bit there. So these are the constraints that you could discuss there. Now, opportunities for technology-led modifications. So simple thing is, they moaned about moving it from one control panel to another. The old system was, they didn't like it. It was basically crap, wasn't it? So if we put a motor in the work platform, you could easily imagine that the operator can move from one control panel to another without even getting off the platform. So that'd be a nice thing. Now, this is an automation type of business, so why don't they automate it where you can program it to actually go to the locations of the control panels via following a cable in the concrete floor, or use GPS, send it there, and all it's got to do is look at these markers and light itself up there. So this helps the engineer. So when the engineer needs to go to a certain control panel, the platform is there waiting for them in position to be used. As simple as that. Now, I've kept that quite simple. Now, you know what you're working on, okay? You know, I can't help you with what you're working on currently. Could I answer in a similar fashion for the product that I'm designing now? Okay, now that's all I've got for you. Hopefully it's a short video. I've got to do the editing now. I wish you all the luck in the world. I hope you do get the decent marks or the higher end marks to get you out of the pass into the merits or into the distinctions. You all work at different levels, so it all comes down to how you cope with this. So we're actually at the end of the video and the series of the how to tackle this exam here. So wish you good luck. Give it a good go. If you've watched the videos, watch them a couple of times, whatever you need to do. List my watch hours up anyway, but we'll go from there. Ciao for now. I'll see you in the next one. Remember, I'm doing Project Next. So when you are doing Project next year, think of the geezer, you come back to see me, and I'll help you get through that as well. Ciao for now.